Keyboards and stuff right away. Hi, it's Saturday, and we're here for Battle of Bots. We are here to battle some bots, and I'm excited. I'm pumped up to try some things. We saw some issues last week, and I'm gonna talk about that in just a minute. But before we get started, while we're getting organized and worked up, we're gonna check the sound and make sure you can hear me. That looks good. What else? We get the feeds and cameras and things. So I will start by saying that I'm the founder of the Lift and Shift Foundation, but I'm also a member of the design team. And our design team at the nonprofit is a group of volunteers and veterans who help work behind the scenes to create Battle of the Bots as a real program that happens in person, where we learn to fight robots and do all kinds of stuff like that. You can read a little bit more about the nonprofit. There's the whole About Us section on the Twitch profile, the Twitch page, or wherever else you're catching this. There are links to go everywhere. But we do this online to kind of encourage people who can't participate with us here in New York City, because it is a New York City event, and we do this live. As we share what happens live, and we share with our design team, we're kind of just bringing it onto Twitch and letting people join us for robot battles. And we're getting reorganized. We took the spring to develop our line arena into a circle-shaped arena, and you can see my hand right here. I'm literally like right next to it. So it's been working out really well. We finally had some battles last week. We completely redesigned our robots, and I'll talk about that in a couple minutes. I'm gonna, like I mentioned, I'm gonna put away my keyboard. I'm gonna put away this stuff right here because I'm gonna work on a tablet, and I have too many notifications here. But I'm also gonna turn on an app on my phone so that I can control the stream from my phone. Since we're kind of like in the educational phase, like I like to teach people and show people how to do stuff. We're using the Streamlabs desktop app to stream, and we are connected on Zoom, so any of our design team members can join in on our Saturday robot battles and to actually take part. You'll see the bigger view in just a minute as I get into this. But I'm really just here as the host to kind of like get the software into the robots and assist in any way I can. I'm not really the we'll call me the ringleader, I guess. But I'm going to control this stream from my phone so I can get rid of this keyboard. So Streamlabs has an app that you can download that has a bunch of buttons here. I can actually shift and right back here, right from my phone, so I can set aside a few extra things here, and we can chat. I can share my tablet screen because we're all connected, like I said, in Zoom. So our tablet is connected in Zoom, and the view you can see from my phone is my other phone is actually from our Zoom stream. And we have some design team members here today. You probably catch me chatting, and you don't see anything in the chat, and that's because we're chatting in our Zoom chat. But that also means that people can join us. People can join in, and we'll be inviting other groups, other robot teams to kind of show us what they do as we wrap up some of the loose ends in this arena and this match and this code and our new setup. So here we go, and I'm gonna quickly just share a quick update because we've also been our design team does a few other things that we right now have a project where we're designing some prizes and trophies and things, and I just want to share and show it off really, because it wasn't even my design. It was the design team people uh, fired up to do things that we're going to give to other veterans, other family members who want to join us in person, and it's a cool thing for people to go home with after they spend a day battling robots. So I dig it. But we're gonna set that aside. So last week, just to briefly get into recovering what happened, we had some sumo code, and we were on the sumo mat right there. Yep, right there. And our robots were not doing what we wanted them to do. So we wrote a whole new set of code. What was happening was, our robots, as you can kind of see right here, I will change the view so you can see. Come back to me here for a minute. We just kind of came back to this idea that maybe the line sensors were interfering with each other. Maybe the distance sensors. These sensors work on a signal where they are broadcasting out of these eyes, and the signal is supposed to bounce back. And what occurred to us in the chatting about it was that our signals might be the same, and it might be interfering with the other robot. So over the week, we met again, and the design team, we meet whenever we can, really. But what we did was we set up some tests with smaller robots that don't go with all the big batteries and tracks and everything else. So we set up a smaller robot to test, and I just happen to have that robot right here. This is the smaller MBot, and we set up 2 sensors on this MBot, and we tested it and we checked it out, and we could not make our 2 sensors trick the other sensor into thinking that it was shorter distance or longer distance. So we want to confirm this. We're gonna today take a few minutes to write some code and set these robots up to confirm the exact same thing. And while we're doing that, we're gonna take another question that some of our design team has been asking, and that's about the angles that we recessed our sensors in. So you can see this MBot. Let me switch views here again. Start with, and we're going to use that code to light up some lights on the robots and to tell us about distances, so that we can set them here on the arena, and we can watch the responses to the distance sensors. So let's get into that now. Let's do that. I'm going to break out a tablet. We're going to share a screen with a tablet, and I think we've got this all worked out so that I can share my screen with the design team, yet still share my screen with Twitch, and that is the glorious setup of scenes in Streamlabs. So let me have a little glass of carbonated juice. And let's check it out. Let's see how we're going to do this. I'm going to share some screen here. We're going to flip to a different view. Dun, 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 dun. I am going to turn on the app, the M-Link app for our robot. We're going to get into Make Block right now. And let's see if I can share my screen. Sharing my screen now with, ooh, that's a crazy view. I need a mouse for that. There we go. Excellent. Cool, so now I can share my screen. I think I can share my screen with everyone. Well, that's not the screen I was looking for. Oh, maybe. Wow, it's like this got all butchered. I did not check this part. Zoom, where are you? Oh no. No, yeah, you can probably only see me like in person on Twitch right now. There, oh. There. Wow, that's terrible. Why is it zoomed in on that? Okay, 1 second. No. That is amazing. Capture cursor, yeah. There. Why did it not do that before? That was painful. No. I am struggling so bad today with this. There. Oh my gosh. I don't know how that was not what I expected, but we got through it. Excellent. Yeah, so let me find me on, let's see if this works. Yeah, you should be able to see me here now. Hi. Okay, and you should be able to see my screen. So design team members here with me. So the first thing we want to do in Tinkercad is get rid of these devices and stuff. So we're going to set up our ranger, because that's what we want to make some code for and do some testing with. And let him go. Okay, so I want to zoom in on the boxes. We need to test our ranger, right? So we want to test our ranger, and we want to have him do some stuff when he starts up. Let me check out the zoom for that. Cool. Very cool. Okay, so we've got this we've got these two sensors. We've got two sensors on the robot, and We want to know what it sees for distance for each sensor. So let's start a loop, right? Because we want our robot to listen forever. We want our robot to be asking, what am I supposed to do next? So forever, our robot will ask a question. Does the distance sensor see something? So we want an answer back. So we want it to be a yes or no. We want it to turn the lights on or off. So let's do this. Let's add an if then else statement for the left sensor and an if then else statement for the right sensor. So we need to now, if it detects a distance for the sensor that is less than a certain size, so we need to have a less than right here, because that's the question we're asking. Does this distance sensor see something less than 7 centimeters away? And in fact, we will do 8 centimeters right now. Just like that. Cool. I want to turn on. I realize I don't have on our. Oh, I would see it. Never mind. There would be a little, thing that says you have a chat in Zoom. I realized last week I missed the whole Zoom chat things. But so here we go. So back to this part. Our distance sensor, called an ultrasonic sensor, on port 10, and our second one on port 8, right there. That's the question we're asking. If it detects an object, yes, I see you. Right now we're working on the Ranger. Last week actually on Tuesday we checked the MBOT. So this time we're gonna turn on both sensors, and we're gonna see what's in the way of each sensor, and then we'll just turn both robots on and move them around a little bit, and see what fails for us. So I think we will. I do have an MBOT out, but it's gonna go away here in a minute. In fact, he can go over here. I was getting all excited about the batteries, but yeah, okay. So where was I? Oh yeah. We're gonna test. Let's see if I can see. Yes. Oh, it's very hard to. My screen resolution is down way too low. It's the MBOT Ranger is. If I crank that up right there, you can see it's an MBOT Ranger. Yeah. I know it's weird that they call it the MBOT Ranger. I'm gonna shrink that all down right there. Cool. So we are looking at the Ranger. When the Ranger starts up, forever, the Ranger is going to be listening to the two sensors, and if the distance in front of it, if the object in front of it is less than 8 centimeters, it's going to turn on the lights. It's going to show us we're going to have to pick 4 colors, right? Actually, how interesting. We have a dilemma here in the fact that we can't test both sensors at the same time, right? Because we can only light up one color. So, what might we do about that? Okay. So let's talk through this. What else? We could try to flash both lights. Maybe that's what we do. We leave it on for like a half a second, so we will see two flashes of light, and they will change color depending on what's in front of them. Or we can test one sensor at a time. I'm thinking. I'm looking at the code on up there on the screen, and I'm thinking. I don't want it to go crazy flashing. So maybe we test one sensor at the same time at a time, but also maybe we can make it. Maybe there's something else it can do.
Maybe one sensor plays music or something.
Oh, that is an idea. We can try that. Well, let's try port 10. We'll light up with color green. Cool. Otherwise, it will light up with red. And let's try your sound sensor. So we will play a sound for 1 second. And it will be a very low sound. Actually, let's use beats. I don't know what beats there are, so we'll just go like from the top and the bottom. Like kind of like that. Excellent, excellent. Okay, so we're gonna try this out. We're gonna set the robots up. We're gonna upload the code to the robots right now. We're gonna set them down, and then we're gonna put them in various spots and see. Actually, let's take away. It'll only play a sound if it hears something. How about that? If it'll only play a sound if it sees something. That way, if this goes crazy, at least it won't go crazy, annoying us with a super annoying sound. So if we take that away, then I can always, if the noise gets too much for us to chat or things while we have the code running, we can pull them apart, basically. Okay. So this is super short code, super easy, and we can put it in both robots very quickly. So I'm gonna grab a cable right here. Got a cable, regular USB cable. Dun, 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 dun. So these robots are not going to be, they're just going to be stationary, they're just going to be sitting on the mat, and they're not going to do anything other than light up, and that'll give us the ability to test. Somebody's excited. So let's see if we can connect to this robot. On COM 3. We want to upload your code. Code is uploading. You can see it on the screen. Code is compiling, uploading. You can see some flashing lights over here. And there we go. This robot is now running the code that we saw. And you can see there's a red light on right here. So that means it does not detect anything within 8 centimeters of port 10 over here. I can move my hand so that that is the case, and it sees something within 8 centimeters. I can also move my hand over here, and you can hear the noise. Cool, we could actually make songs. Like you could have your robot play Jaws or something as it's sneaking up on somebody. But we got this robot running. We're gonna power him down, set him over to the side, and we're gonna code the second robot right here, the exact same set of code. So power is plugged in. Dun, dun, dun. Robot is plugged in. Let's connect to our robot. Connected. Oh. Uploading our code right now. You can see some flashing lights, and now you can see it's doing the same. It's doing the same thing. You can't hear sound. Oh, you couldn't hear the sound. That's weird. It was really low. But okay, cool. Yeah, I think we're ready to do some testing. So let's switch some scenes here. I'm gonna put the tablets out of the way. Switch some scenes over to. Nope. All right, so where were we? I don't want to click to join audio. How about that? Cool. Okay, so what we were just testing right now was the fact that we have two sensors on these robots, and they don't consistently interfere, but both robots are using a sound to go back and forth. So the sound, they're kind of like yelling out and then listening for it to come back like an echo, and they're using that just like bats do, and sometimes dolphins and some other animals who can't see really well. They kind of like chirp and do things. So our robots are doing that, and the sound they're using is occasionally the same sound that the other robot is looking for. That's what I saw right here. So I don't want to say that there's solid interference, but there's intermittent interference that we saw, and we not only did we see that, but we saw that when we turned the one robot off or on, there was an increase in what the robot thinks was in front of it. So it was a bit inaccurate as far as detecting objects in front of them. So last week we were correct. We were right to skip the distance sensor. I think changing the mount for our distance sensor is probably not going to help. Changing the angle. So we discussed this idea that maybe our robot had a problem with the angle, and it didn't look like that was the problem here. Although it did seem to kind of like impact or change the way the signals were perceived. I don't think that if we turn the eyes straight back to forward position instead of the 15 degrees angle, I don't think that will solve the problem of sensors getting mixed up. It's in our best interest to stick with the code we already have. So what I'm going to do is I'm going to break out the code we already have. We can have a battle today because we're here. We have everything set up, and it's Saturday. It's Battle of the Bots. But I'm gonna load the base software we have. Check it just to make sure that it's there and I don't have the wrong one. I'm gonna drive the lift and shift bot here, I think, and let our design team code for the SaneSmart bot today. So if you do want to have a set of code or want to work on a set of code, and just drop it in the chat like we always do, and we will have our best 2 out of 3 Battle of the Bots right here on the Sumo Circle today. And that's probably how we'll wrap up. We can go back behind the scenes and talk more about what we might want to do with the eyes. I think possibly nothing, or go back to the original setup and just use the one. But yeah, we can chat about that as a group in the channel. But I am gonna move some stuff around on a screen and share a different view. Let's see if I can. Ooh, wait. Ooh, you are ready with a file. Snap. Okay. Design team is ahead of me. We've already got a file uploaded, and I'm going to share this process with everybody because we don't drive the robots, we don't control them. They're autonomous. Our design team sends the code to me. I upload the code just like we did a few minutes ago with the test code. And I'm about to do that right now. So I'm going to share that from my perspective. There we go. There's the big view. So I'm gonna open the code that Oh, so close. You sent me an image. It looks like a picture of the code. Yes, you actually got one block. It looks like you got a picture of one block. That's kind of funny. But I am going to open up our standard code right here from, and we're not going to save what we were just doing. From downloads, I'm going to do a regular code, and we're going to check this out. This is our setup, and I think the one we've labeled base is the one that's using the ultrasonic sensor. So it's using the distance sensor. So we
just want circle base
yeah exactly. You want to use number the one that's numbered actually 1. If we open that, there we go. So this one is based on our line sensor. So I can chat a little bit about this and say that this happens when the ranger starts up. And when the ranger starts up, he's checking to make sure he's still in the circle. If the ranger is not in the circle, then he's lost. He's lost the match. He's gonna flash a bunch of lights down here at the bottom and play some sounds and things. If the ranger still has part in the circle, it's gonna do one of these moves right here. That's if the ranger detects part of it underneath of it. It's gonna do one of those things. Those are defensive moves right there, where he's gonna turn left or turn right to try to get back into the middle of the circle if he's on the edge. Otherwise, he's gonna try these moves right here. Starting with this block right here. This is his shake and bake, his moves, and I see our design team has a file ready, so I'm gonna download that. I'm gonna download it to the download folder. Where did you go? Downloads right there. Very cool. Alright, so I just downloaded code from our teammates. We're gonna upload code into these robots right now. So I'm gonna do the reach. We're gonna get this robot turned on, plugged in. He sees something somewhere. You see something is reflecting back at him because he's just buzzing away. So I'm gonna get started uploading the standard code that we have into the lift and shift bot. So I'm gonna connect to the lift and shift bot, and we're gonna upload this standard code right here. Upload, compiling, sending. You can see some flashing lights from the Bluetooth right here, and you can see now our robot's actually running the code that we've prescribed. We've told him to run. So now the super easy part. Design team code. We're gonna open that file. Really doesn't like me doing that. So we're going to open up our design team members code right here. I'm not going to take too many quick peeks at it. I am just going to see that it will, if it doesn't detect a line under it, it will stop moving and do a bunch of stuff, which is kind of like the rules for us. So we're going to grab the SaneSmart bot here. We're going to get the SaneSmart bot the same treatment. He's going to get code from our design team member. We're going to connect. Connected. We're going to upload. Upload progress. You can see compiling, sending, uploading, actually making things go. Look at that. Somebody's excited. The code just starts happening right there as we go. And that's it. So our robots are full of code. So we come back to the me view here for a second. We just loaded up the code, that code up there, for both of these robots, and it's a separate bit of code for each one. I coded the lift and shift bot, and one of our design team members here behind the scenes has coded the SaneSmart bot. We're gonna wrap up the stream today and have a best 2 out of 3, because that's what I do, and it'll be here on the circle. So the goal of this match is these robots want to push each other out of the circle to win. That's basically the concept, the challenge, the problem we're solving is that there are 2 robots in this ring. We want one of them out. Somebody's got to go. It's like a regular sumo match or a wrestling match, and both sensors will start in that ring. We'll see how well we coded our robots to handle an opponent, and we're going to go best 2 out of 3. I may give some commentary as we get into this. I might say like what I see or what might be happening based on me being here in person. If we got to call a match, I'll call a match. If batteries go flying, usually whoever has the most batteries fall out is the loser. And yeah, let's get into it. let's go there. Yeah, so there we go. So here's our match. You can see it up there on the other screen if you were on Twitch with us. So our robots, we're winding down after testing some of the sensors. It seems the distance sensors on the Arduino packages do interfere with each other if you're using more than one facing each other, and that's interesting. We couldn't make it happen on the MBOT, but we saw it intermittently today on the Ranger, and I think that is a little weird, but not surprising. I think also this leaves us as robot builders and nerdy people in general, this leaves us with a few options. We can ditch the extra sensors. We can use the extra sensors maybe somewhere else. And I think this also means that we can start giving robot operators and teams options to customize their robot. And we're going to have to chat about how we do this behind the scenes here, but we're going to have an opportunity for teams to start customizing their robots and making this even harder. And that's going to be the challenge in how we do that logistically. I think our design team will end up with a box of parts and a few extra things here or there. We have this we have kits that are coming in that have like extra servos, extra arms and stuff like that. But already right here, I see where we could use the line sensor and the distance sensor in different places. And some of us have been chatting about the fact that maybe the lines, maybe the distance sensor, the eyes in the front don't need to be in the same place, and they don't need to be 15 degrees spread out like this. So that way we can change the information that the robot gets, and we will start giving our robot designers the opportunity to not only just name their robot and have a sponsor like SaneSmart or the Lift and Shift Foundation, but also customize the attachments, and that should make things a little more lively for teams and give them the opportunity to build more, do more, and actually have the information they want for the code they want, and that should be fun. That should be fun in the future. But for now, we've got these robots and they can do things, and we can start incorporating our line and our sumo ring in future events, and we will break out a smaller MBOT for the easier or earlier rounds, and for later rounds we'll move up to a harder session or a harder experience, a difficulty level, if you will, and let this happen with the larger robots in the sumo circle instead of the sumo line. And this ties in a lot to some of the things that we do here in person, because one of the events that we do here in person is a sumo battle on the line, and having that happen here on a stream, it is a very cool way to kind of connect the online and in-person parts of our program, because like I said, we do this in New York City locally, and not everybody can attend, not everybody can get to us. We really wanted this to happen in a place and in a way where we could reach people who can't join us in person, and that could be an injury that somebody has where they can't get out of the house. It could be childcare issues. It could be any number of things that keep people at home, and that's the entire purpose of putting this online and putting this out there, so that people can watch it, people can check it out, say, hey, look, those robots are fighting. That's cool. I want to do that too. That's really it. I think at this point we're probably done with the stream for today. We got some battling in. We tested our sensors. We have some ideas as a design team, as a bunch of people who have been designing some of these 3D parts for our printer, or for our robots. We'll regroup this week and maybe chat about what we want to do different. I think next week will just be a series of battles, and we'll actually work on the event and get some highlights to actually share with people and say, look at this, look at these crazy robots. We might actually get off the floor next week. I have a table on the way. We'll try the table out and a new camera, some different views, that kind of stuff. I hope it will be a good experience for everyone, and a better experience too. So it's I think I will end the stream with a video that shows everyone what Battle of the Bots was like before COVID, before we knew that everything could be done online. And I appreciate everybody who helps and participates and joins us, and you can go to the About Us page if you want to join, click links, any of that other stuff. I'm not gonna do too much pitching right now. I'm just here to say thanks. This was cool. This was good. And here's our highlight loop.
Has gone wrong. Wally, don't do this. Don't worry, Wally. In your house, don't smoke it. You know what I mean? Like, walk
for this side. On your mark, get set, go. Point for this these guys.
Let's go. Have at it. Oh! Oh, and they're struggling. But they're not giving up. It's still a fight. It's still a fight. It's still a fight. What are they? There he is!
So, yeah. Oh,
He's-
who got it? Who got it?
Best 2 out of 3.
3, 2, 1.
Go. Go! Have at it. Oh! 2 batteries down. I think that might be a draw.
Yeah, I'm gonna call that one a draw.
That was hysterical.